Are you guys ready? All right. Put your phones away. Thank you. Simon. Thank you, dear. Okay, so here we just kind of touched on this for the first earlier this period. It says that the symbol for square root is the square root symbol. Hopefully you're familiar with the symbol square root, and all it means is in algebra 2. I want you to think about it. It is the opposite of squaring, kind of like how the opposite of multiplication is division, the opposite of addition is subtraction, and all those, okay? So think of square root as an opposite of squaring and vice versa. So the examples I have here is, you know that 4 squared is the same as 16, and then if you take the square root of 16, you should get the 4 back, okay? So there we go. So what is 3 squared? 9, which means that the square root of 9 is? Square root of 9. 3. Yes, square root. Okay, so we're just going back and forth, okay? What squared gives you 121? 11, okay? If you, I put the multiplication table here. Well, obviously 11 is not on here, but if you look at the multiplication table, just the multiplication table you learned in elementary school, it's right here. And the diagonal right here are all of your perfect squares right here, right? So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And the square root of 100 is the 10. Square root of 89 is 9, because 9 times 9 is 81, and then so on. I just thought you wanted to look at this. Okay. What square root is 11? So what can I take the square root of to get 11? 121. Okay. Can you think of a perfect square?
49.
49 is a perfect square. And then what's 7 squared? Which means that I can do square root of 49, and what should I get? 7 back. Okay, so just kind of think of it in that sense. And also, I wanted to review prime factorization. We did this last week as well. When we do the prime factorization, we take a number, like for example 72. This is the same example I had in your other lesson. And you think of 2 numbers, multiply together to give you 72. 9 and 8. Do I have any other numbers? What else goes into 72? I chose 2, so 2 times 36 is 72. Okay, is 2 a prime number? Yes, it is. So I'm going to circle it. Go to 36. What is 36? 6 times 6. And then here, what is this? 3 times 2. 3 times 2. Okay, and I'm going to circle these. So I have 2, 3, 2, 3, 2. Same thing here. I have 2 3s and 3. Hey, I have 2 3s and 3 2s. Okay, whatever. That's same thing here. You'll get the same thing. It doesn't matter what numbers you start off with. But this here is called prime factorization, where I keep going down. It's called a factor tree, until I get only prime numbers and I circle it. And in the end, if you take all these numbers and you multiply together, so if you do 3 times 3 times 2 times 2 times 2, you should get 72 back. Okay? 3 times 3 times 3 times 2 times 2 times 2, you should get 72 back. Okay? All right, so let's go to our lesson here. When we are simplifying square roots, and it's not a perfect square, so for example, if I want to simplify square root of 20, and I always start off by putting it in the calculator. Okay, so if I look at square root of 20 and I hit enter, So I got a decimal, which means that this is not a perfect square. And I cannot write a decimal here. I have to like simplify it. Okay? So to simplify it, I start by doing the factor tree. So I'm going to write 20 here. And I'm going to look at factors of 20. What's 20? 5 and 4. Is a 5 a prime number? 5 times 1. But since it's 5 times 1, I'd leave it at 5. What about 4? 2 and 2. And 2 is a prime number as well. So what I'm going to do is I'm going to rewrite this as 5 times 2 times 2. And then at this point, just remember that for every 2, not the number 2, but for every 2 numbers that you have under here, 1 comes out of your radical. I'll show you. Okay, look under your radical. Do I have a pair? I should say for if. Let me rewrite this. Now instead of saying for every 2, I can say take out pairs. All right. Do I have a pair here? 2, right? So for every 2, one of them comes out. Okay? Yeah. And then so 2 square root of 5. Okay, so just note that square root of 20 is simplified to 2 square root of 5.
That's the simplest way.
Simplest, yeah. You shouldn't have any others like perfect squares under here. The reason I should explain this, what is the reason I did this was, because let me just kind of put this all back together. If I say the square root of 5 and then square root of, what's 2 times 2 here? 4. What is the square root of 4? 2. So that's where the 2 comes from. And then you have square root of 5 left.
So either way, you always have that one.
Either way, yeah. I rather do it this way here. I like this way because, I don't know, this is just too tedious to do all of the factors. So, but I do have to show you this so that, you know. So now I'm going to look at 70, this one. So what I'm going to do is I'm going to do the factor tree. I'm going to look at 72. Hey, this is the same as what we just did, right? So 72, what did we say? 8 and 9, or actually let me go with 36, because 36 is a perfect square. So this is, what was it? 36 times 2, okay? So if I rewrite this as square root of 36 times square root of 2, what is square root of 36? 6. So this is just square root of 2. Okay, so you can do it that way. But let me do it the other way, okay? So I'm going to keep going. 6 times 6, 3, 2, 3, 2, and then you have this 2 here. Okay, so I can rewrite this as square root of 3, 2, 3, 2, and then 2. Okay, so since we're doing square roots, for every 2 pairs, for every pair, one of them comes out. Another pair here, it comes out. And then you have square root of 2. And then you have 6 times 2 is 6. 3 times 2 is 6. Okay.
How'd you get to 3 times?
Oh, because, so when I did the prime tree right here, I put all the numbers here, 3, 2, 3, 2, 2, 3, 2, 3, 2, 2. And then for every pair, so a pair of 3s, one of them comes out. For every pair, 1, so 3 times 2 is 6. All right. Okay, so I'm just gonna go through these 3 examples and then I'll put up your exit ticket. All right, so let me look at square root of 179. Let me do the factor tree actually. So again, it's a lot easier if you look for perfect squares. If you know your perfect squares, this will be a lot easier for you. So I don't know what goes into 175. Well, 5 goes into it, right? All right. I know that 175 divided by 5, 25 times 175 divided by 25. Oh yeah. Good. Let me use that. 25 times 7. So you can see your answer will be 5 square root of 7, right? But I'm going to keep going here. So this is 5 times 5, and then you have your 7. So I'm going to rewrite this as 5 times 5 times 7. So for every 2, one of them comes out. Square root of 7. One thing I can tell you that is I would, whenever you ask to simplify radicals, I would first try it out in your calculator to see if you get a whole number, okay? So for this one, because I can already tell 144, I think that is a perfect square, but let me just check it. Square root of 144, 60. Because square root of 144, I believe, is a perfect square. Yeah, 12. So 12 times the 5 is 60. That's how they got it, okay? So there's nothing else to do here. I'm just going to put 60. Hopefully I have the same luck with number 5. Let me just plug it in my calculator. I have a bad feeling, though. I don't think it's going to happen. Yeah. Square root of 343. Oh, man. It's not a... It's a decimal, so I have to do the factor tree. So let me look for one. So let me do 343 and then do the factor tree. What goes into it? 343 divided by 3. No, 343 divided by 12. Remember this other trick I showed you guys? If you want to look up factors, just go to y equals, put 343 divided by x, and then go to second table, and then look up factors here. There it is, 7 and 49, okay? So 343 is the same thing as 7 times 49. I know 49 is a perfect square, and that's 7 times 7. So to read, okay, if you have a number in the front, just watch what I do. So I do 12 square root of 7 times 7 times 7. And then I know for every pair, only one of them comes out. So you're going to do 12 times 7, square root of 7. So 12 times 7 is 84. That is my answer. I think that's, yeah, we're gonna do this tomorrow.